Okay, so I've got PlayStation 5 open already, and yeah, I'm going to check it out as to what's happening. So first things first, this thing was opened before because the seal was broken, but then I would assume it was opened to put this SSD. It's a 2 terabyte Samsung Evo for 940, I think. Yeah. So the first thing that I'll do is I'll check to see if there's any voltage, but you can see here this has never been removed, so this is probably not been opened to the motherboard level unless they did the same thing that I just did now. But I doubt that they did, that reason being there's still the network cables, so you couldn't have possibly pulled them out like that. This you have to rip out. Okay, so this is a disc version PlayStation 5. Yeah, I don't know which is better, the disc version or the non-disc version. You can see there's still a screw there. Oh, I've never noticed this screw with other PlayStation 5s. Or maybe it's because I don't get to open them most of the time. Someone opens them and I just fix it. Okay, so I've got the console out. Here is the power supply. That's where we're going to start. So I'll check for 12 volts. I'm supposed to get 12 volts over here. So from the other repair video that we did for PlayStation 5, we found out that there was no 5 volts. There was no 12 volts from there. So what's the outcome with this? Same result. We don't have a 12 volt. So which probably means our console is fine. What I'll do before I conclude that the console is fine, I'll check for a short across the 12 volts main power relay, and it's okay. We've got kilo ohms of resistance, 23, and it's still rising, so this is fine. This simply means we didn't get a short circuit from the console, so we are probably okay on the console side. So let's check the power supply then. We can check the power supply and then see a way forward from there. I opened this before. Alpha, Omega. He sits upon the highest one, highest of all. He is a maker, creator. Okay, here we go. I'm gonna avoid touching those two because you know there is no a lot of charge. This supply looks like it's got bigger components than the others up here the other day. Let's check what we have inside. Why does it read OL on voltage? What is happening? Okay. So you can see it's actually charged. Lucky enough, I checked first before deciding to touch them. How am I going to discharge this? I need a charger. Okay, where are the two? There's somewhere here. Okay, there you go. I think you can see the red LED there. Yeah, it's still discharging. It's still charged. I just wanted to drop to a self voltage which I can short out. So how many volts is left? It's still 248. It has barely done anything. Let me grab a soldering iron. This should be able to take quite a lot. Much is left. 20 volts. So soldering iron is way better than a small charge. Anyways, now we can do that and it's all discharged. So if we've got voltage over here but there is a void, it definitely means we have no issue with our diode, and it means we have no issue with our fuse. So our fuse is fine, our bridge rectifier is okay, it's fine, so we have no issues here. But for some reason we do not have a 12 volts output here. So if you take a look over there, it's now getting a bit brown. It's getting brown there, so I would suspect we have an issue right over here with these two MOSFETs. So what do we have? It's dead. It shouldn't be passing like that. This one is definitely dead, so these two MOSFETs are dead. Okay, I hope that's all we have. Let's check any other MOSFETs that we have. Last time we had an issue with this one over here, but since the fuse is not blown and the bridge rectifier doesn't have a short on the output of DC, this means this guy is okay, because last time when it was faulty we had all those issues. So this time it's okay, it's fine. And this diode is also fine, it's also okay. Then we've got two MOSFETs on the other side here. We can check them out over here, and we are okay. We are okay. Yeah, so it was just low resistance and it keeps increasing, so it's not a short. But here we are dead, definitely. So I'm gonna take off these two MOSFETs and hope to alleviate our error through that. So we're gonna add some solder to it like that, to the pads. This should allow the MOSFET to come out much easier. There we go. That's number one. We can measure it across. And what does it have? It's dead. So we have a dead MOSFET here. Problem number one. Let's take off. Let me check before I remove it. We still have this short. So you can clearly see this is a cap and it's got a short across it. Because you would think that maybe it's supposed to be like that because this other side is not short yet, but no. The cap is also giving a short. Let me take it off and see if our cap still has got a short circuit. So this one was a bit obvious because the board was getting bent. It was now changing color. Okay, here's number two. And what do oh no, this is dead. Look at those. Look at those. Look at those. They're supposed to be silver, not funny color grayish. There we go. It's 4 ohm resistance. It's a 0 ohm resistance. So this is dead as well. So we need 2 MOSFETs to be able to fix this power supply. Give me a moment. Let me check if I've got a power supply that I can yank some parts from. Okay, what's up guys? Okay, I'm sorry I had to continue this off camera because I didn't want it to be as long as the last video. So if you remember my last PlayStation 5 repair of the power supply, it lasted something like almost an hour. It was 59 minutes, I think, something like that. Anyways, so I took the chance to kind of experiment with this power supply off camera. Anyways, I'm just gonna give a recap of what was happening. Let me just make sure this thing is drained. I don't want to be barbecued by this thing. And like I expected, it's not. So it's got like 300 and something volts in there, which is quite a lot of voltage. I'm not even fleshy, I'm too skinny to be electrocuted by such voltages. Okay, there we go. So, alright, so the last day, because it's no longer the same day, by the way. The first day that we opened this power supply, we discovered that there was an issue over here. These two were blown, so you can see that orangish color there. Yeah, the brownish color from heat or something like that, or something similar. So that's where our issue was. However, after replacing these two, remember I replaced them with where's the first pair that I used? I'm not so sure where I put the first pair. Oh, this is the first pair that I used. I'm not sure why my screen is gone dim. Oh, I've got 5%. I didn't notice my phone was not charging all along. Just give me a minute. Okay, so the phone is charging now, and I hope the charger can sustain me recording a video. And I don't think it can, because this phone records in like 8K. So yeah. Anyways, the first pair that I used was this pair. But after having to go through the data sheet and proper research, this was not a good set of replacement MOSFETs. So we removed these two and we put these two that are currently there. But the power supply still didn't produce 12 volts. So after that, that's when I stopped recording the video. And today I took a power supply from a desktop and I removed these two. They're quite similar readings as these. So this is 600 volts. This is the dead one which was there. These two, they are the dead ones. They are rated for 600 volts and 13 amps. These two are rated for 600 volts and 12 amps. So yeah, it's not really a big margin of a difference, which is just the same as these two as well, 600 volts and 12 amps. So before I put these, I took a moment to kind of research online, but I couldn't get any information about this power supply. It's just people repairing the power supply. They don't really say anything about the components that are on the power supply. So I took a power supply from a PlayStation 4, this one. So I followed these two MOSFETs would be corresponding to these two over here, and just before you get there, there is a resistor on the other side, this one. I measured that resistor, it was at 0.1 ohms. So basically it's more of a straight wire. But before I measured that, the reason why I measured was that I looked at the resistor there, because I tried to follow the voltage. So from all over here, I'm getting like 330 something volts here. I follow that 330 something volts up to where the resistor was, which is this resistor. So it was ending there. On this side, there was literally no voltage at all, no life whatsoever. So I also got kind of confused over here. There is a capacitor right over here, and if you measure across it, it buzzes. It's got like 0 ohm resistance, and yet it's a capacitor. But then it's not dead. not yet. Remember, there is a coil, so there's a coil over there. There's coils actually inside there, so they go right around and then they come back there. So yeah, you can expect that. That's not an issue. So most of my time was wasted over there, over around that capacitor which was buzzing. I even removed the one side of the coils to try and see if I can eliminate that. But then I measured the coil from a PlayStation 4 power supply and the coils from a PlayStation 3 power supply. They all buzz, so my assumption was that that's how it's supposed to be. Anyways, from there, that's when I got the idea of checking why my 300 volts is ending over there. It's 330 volts, I believe. So I just googled the color code of the resistor. Lucky enough, it's the old and well, the type of resistors that we are taught at school. Actually, I didn't go to school for this. Anyways, the color code, that's what I googled: brown, black, silver, gold. And according to the internet, it was a 0.1 ohm resistor, which is basically a straight wire. That's why I took a moment to measure the resistor on a PlayStation 4 and to measure a resistor on a PlayStation 3. So this resistor comes just after these reservoirs and just before you get to the two MOSFETs. In this case, they are over here. So just before you get to these two MOSFETs, you get a resistor. Similar to here, just before you get to these two MOSFETs, you get a resistor. And same applies to this side as well. Just before you get to the MOSFET, I believe here it's only this one, you get a resistor, a 0.1 ohm. So I tried to measure the resistance across this guy, and funny enough, it was basically an open line. There's nothing, no response at all. So I replaced the resistor with this one that's coming from a PlayStation 3 power supply, and yeah, and that solved the issue. So I was right in the first place to say the MOSFETs are dead, which was quite obvious really. There's no need to be uploading myself. Actually, it was an obvious thing because there was some pen marks over there. But then that resistor, so basically the MOSFETs, I had replaced them, but then they were still not getting any power. So the resistor basically acts like a fuse, because in this case, I believe that this is the reason why our main fuse and our main bridge rectifier didn't blow. Reason being, the resistor was still, it acted as a fuse. So once the MOSFETs died, the resistor kind of cut any supply to that area, thereby preserving the main fuse, which is over here, and the bridge rectifier, which is over there. So right now, when I plug the figure 8 cable, this is the voltage that I'm getting now, and there we go, 12.2 volts. So this is a working power supply now. So I'm gonna grab the console, which is right over here on the desk, and we will plug the power supply inside and test to see if the console is now fixed and working, which I'm expecting to be the case really. But if you remember quite well, I believe you do, because I'm gonna compile the videos into one anyways. So the console, I never got to open the motherboard side of the console. Reason being, there was no need at all for me to do that. Also, I'm thinking of putting a heat sink on those two MOSFETs to kind of extend their lifespan, because the manufacturer just put the MOSFETs without putting any heat sink, nothing whatsoever. So I believe over time the heat has caused the MOSFETs to fail. So I'm gonna plug, I need to see the blue light as well, because I do not have a fan connected. Okay, let's plug the AC adapter and let's power it on. Oh, it's on, it's on. It didn't make any sound, but it's on. There's the blue light. I don't know why it didn't make a sound. I was shocked. I almost cried. Anyways, this is a fixed console, guys. I'm not really gonna bother myself about the display because I don't think there's any issue on the motherboard side. I'm gonna plug it anyways for the sake of completing the rest of the video. Anyways, this is fixed. You can see now it's turned into a white light, so this is fine. This is done. So yeah, basically our issue was with the MOSFETs as well as the resistor that's supplying voltage to those MOSFETs. Okay, let me try to capture the display on my laptop there. So there we go. If you take a look at there, do not turn off your console, blah 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 blah. Yeah, I'm using display capture on OBS, and you can see there your PlayStation wasn't turned off properly before unplugging AC, blah blah blah. So I believe this thing just went off probably whilst it was being played, because this error message usually happens if you just power down the console without switching it off. Anyways, I hope you guys enjoyed the video and you learned something. As always, I will see you in another video. Cheers guys, and goodbye.